Hello everyone, this is day 5 of our Cloud Study Jam series. So today we will be covering 3 major topics. This will be the agenda basically: Cloud, BigQuery and SQL in the first session now, then Cloud Monitoring, and then lastly HTTP Load Balancer with Cloud Armor. So this is the agenda. Let's begin with the first part: Cloud, BigQuery and SQL. So before understanding BigQuery and SQL, we will first understand few key terms. That is, first is database. So database is basically a collection of information, a storage mechanism, right? Query. Query meaning that you ask questions to your database and you get answers, you get insights of your database. SQL, Structured Query Language. This is a tool to perform query on your database. So on the similar lines, now if we try to deduce what BigQuery means. BigQuery meaning that you query on large amounts of data sets or databases. BigQuery is a tool specifically designed for Google Cloud Platform services, and it is used to handle massive amount of data. So I hope we understood what is a database, that is a storage of information. Query, that is you ask questions and get answers about your database. SQL is a tool to query your structured database. Now, structured query language meaning that you query your structured database and get your answers. Structured database meaning how in Google Excel sheets we have rows and columns specifically designed. So that is structured, right? So this is the documentation definition of BigQuery. So BigQuery is a fully managed petabyte scale data warehouse that runs on the Google Cloud. Data analysts and data scientists can quickly query large data sets without having to worry about setting up and managing servers. So I would like to stress on this point. What is cloud basically? I'm relating cloud and BigQuery here. So cloud is something that the service providers, the Google Cloud Platform or AWS or Azure that we see, these service providers lend us their services. We deploy our applications on their platforms. We don't have to worry about managing our servers, setting up our servers, looking into the security issues, the risk issues. We don't have to do that. We are just going to deploy our app. We have to worry about how our application will work, what code our application will have. Rest everything the providers will manage. They will manage our servers, they will see the setting up, they will see the security issues. Similar is the case with BigQuery. We don't have to worry about how our data is going to be stored on Google Cloud. We just have to worry about getting the query results and filter our data sets, get the results, perform complex operations without having to worry about the setting up and managing servers. So this is a gist of BigQuery. You handle massive amounts of data, you filter and query massive amounts of data without having to worry about the management or setting up part, right? So now that we learned about BigQuery, coming to Cloud SQL. Cloud SQL is a fully managed database service that makes it easy to set up various types of databases, relational databases. So examples of that may be MySQL and PostgreSQL. Now, an important thing to note that Google Cloud, when you upload your data sets to Google Cloud, it accepts only two formats. It can either be .sql or .csv, that is comma separated values. So this is the format that Google Cloud accepts, the format of the data sets, and you understood what is Cloud SQL, right? So now this is the hierarchy that we follow. So each project that you create, each lab that you do in GCP, that has a project ID associated with it, right? You have your Qwik Labs username, you have your password, and you have a project ID. So each project has database or data sets in it, and that database contains tables, right? So the basic definition of database, it is a collection of tables. So this hierarchy we already know, but in Google Cloud we have projects. Each project has data sets and each data set has tables. And with BigQuery, we also have one additional benefit that we can access data sets shared publicly from other Google Cloud projects. So if we have the necessary roles and permissions to access, we can definitely access other data sets from other Google Cloud projects. So now the lab that you have for BigQuery and Cloud SQL, that is a very simple lab. It covers these basic concepts that I covered in these few slides, and you can perform these commands, like you can run select command, from command, where, group by, order by. So these details are given in the lab, and the hierarchy that I told you, the format specification, the definition of BigQuery, it can store up to 2 raised to 50 bytes data, and these key terms that we covered. So this was about BigQuery and Cloud SQL, a very basic and simple part. If you do the lab, you will yourself understand how easy it was. So now we move on to our next session, that is cloud monitoring.
Yeah, hello everyone. So, as we've seen in the previous labs, where we have set up virtual machines, we have set up instances, and we can actually set up multiple instances using various methods, like either individually or through our instance templates. And further down the line, we'll also see other methods to do that. So now, for example, let's say that we have a particular company where we're working for, and they are quite popular, and we have instances set up. And on and off, we do face large amounts of customer requests and customer visits to our website. So now, one important thing we need to make sure, right, that whenever our customers like there are loads of customers visiting together, there's a huge traffic, then we need to make sure that our instances do not face excessive of traffic and they stop or malfunction or etc. So for that, like once we have deployed the required instances, then we need to monitor them. So cloud monitoring is basically that our various resources are to be monitored by us or by automated code, so that we can understand that when our traffic is increasing, when there are loads of users visiting our website, and accordingly, if need be, we can take further actions, like for example, introducing a few more virtual machines, instances, etc. Or correspondingly, if there is very less traffic, we may even actually like destroy a particular virtual machine and reduce the number of servers to save costs. So yeah, this was like the basic need of cloud monitoring. So we need to constantly monitor. I mean, monitoring actually serves two purposes, right? When there are excessive users, then you need to increase or scale up your system. And when there are less of users, then you can actually scale down your system to lower costs. So now, for example, consider like you have 10, 15 virtual machines running, a few storage buckets running, etc. So now what happens is you cannot manually go through each of them and monitor them, right? You cannot like, even if you have something like CPU resource managers and stuff, so you cannot you cannot like 15 instances, you cannot actually view them, right? There is no way in which you can do that. You need some automated code to do it. So for that, we have alerts, we have checks, etc. So again, like how we had triggers in PubSub and in Cloud Functions, so similar kind of that, we have alerts and uptime checks here. So we can actually automate stuff, and we can tell Google Cloud to alert us when some particular threshold is crossed or reached. And we'll see that how we can do that in this particular lab. I'll just share my screen. Can you see my screen? Yes. Okay. Thank you. Okay. So we are going to go through this cloud monitoring lab. So first of all, what we have to do is, so now here in this particular lab, it is going to introduce to us how we can set up alerting, set up checks for one particular compute engine. And the first thing definitely we need to create a VM instance, and then we need to add a particular server. Apache 2 is kind of like Nginx, so it's a simple web server which we have, and we need to add that to our instance. So like we have the Nginx default page, similarly we have the Apache 2 default page. Again, basic, simple web server. So I think I'll do this lab with, I'll explain it while doing the lab. It will take a bit of time, but yeah, I think that will be better so that I can actually demo stuff. I think if you all want, you all can do it together, but I don't think we'll be able to solve doubts currently. So if you all want, you all can follow through, and if you all have doubts, then maybe after the session we can do doubt solving. So we just have to create a simple virtual machine with the given specifications. We are using US Central 1A as the zone, and US Central 1, which is Iowa, as the region, and simple N1 standard Go. I hope everybody remembers it. 32 cores with 7.5 GB of memory. And we need to allow HTTP traffic. So basically a firewall rule for that particular instance. So this being created. Created. And now I need to SSH into this instance. Some commands need to be run inside the instance, so make sure that you are SSHing into it and not doing it on your own console. We need to do that inside that particular VM. Karen? Yep, we need to install Apache 2 and PHP 7. And yeah, here they've mentioned if you cannot install PHP 7, you can use PHP 5 instead, no issues. For me, this has worked. Let's hope it works now also. Has worked. Now we will just restart the service Apache 2 so that our web server inside the VM starts running. And we had allowed HTTP traffic, so port 80 is already serving. And let's see. If I go on to the external IP, I can see that my Apache instance is working and I am treated with the default page. Okay, and I did get a success response. Okay, now onto the monitoring part, right? So to set up basic monitoring from the navigation pane, I can go to monitoring, and this is actually a dashboard for monitoring, which is basically a one-stop solution for all monitoring works here. You can monitor various resources, and you can actually see charts. We'll see how to create charts in some time. Okay, so by the time my workspace loads, I'll just explain this. That so basically we need to install a few programs which are called as agents in our virtual machine. So what these programs are, they are actually daemons. Daemons are essentially programs which run in the background and do some tasks in the background. So you all would have seen we have the Docker demo like we had seen yesterday. Currently, we have our monitoring and logging demos, which basically monitor our virtual machine for changes, for shutdowns, for uh, all various different types of system events, and they do collect that data, and then later on through our monitoring dashboard we can actually view that data. So this is an important step where we need to actually install the agents in our virtual machine, and they have said that it is the best practice to run your logging and managing agents on all of our virtual machines. So we'll just simply install the agents. This call is basically for downloading files. We are actually downloading this particular file at monitoring agent repo.sh, and sudo bash will actually run that shell script. I'll do this first. I have to do this inside the game, not in my cloud console. Okay. So I have downloaded this file and I ran it using sudo bash and the apt-get update. And now I will install my stack driver agent. So for the Google Cloud Monitoring was actually previously known as Stack Driver. It was an agent or a program for monitoring as well as logging. Yes, I need to install it. Okay, and now going on to the logging agent, in similar way, I'll just install my logging agent. I'll run an update and install Google Fluently. This is our particular logging agent which we'll be using, Google Fluently. Okay, so these agents have been installed.
Ali, what is Fluently?
Sorry?
What is Fluently?
Fluently is basically our logging agent, and D probably stands for daemon. So this is Google Fluently daemon. And now we will create an uptime check. Uptime check is basically kind of similar to our health checks, which ensures that our resource is always available and accessible. So we'll just create that, and that can be created from our monitoring dashboard. Uptime checks, and create an uptime check, and the title. Let's see what title we need to give. I think, yeah, LAMP uptime check. And we will see that the HTTP protocol has to be checked for each uptime status. This is the URL. Let's leave resource type. Where is that? 1 second. Yeah, we need to Uh, yeah, we need to make sure that our instance is upright, and it's a single instance, which is lamp 1 VM, and we'll leave the path at default, and this check would run every minute. Next. So via HTTP, it will ensure that we'll use the HTTP protocol, sorry, and we will ensure that the LAMP1 VM instance is up, and we will check that every minute. And yep, we just okay. So in 281 milliseconds, we got OK, which is 200 status code, which basically means that our instance is running. Uh, yeah, response validation for now we don't have to make any changes to this. And yeah, if the status is, the VM is not running, right, we do need an alert. So this is basically to create an alert. And now we can create this. We've already tested. We just create it. Okay, so our uptime check has been created. And now we need to set up alerting. Alerting is basically to alert us if there are some issues, and we'll create an alert policy. So we can track some particular conditions. If I click on add condition, we have different metrics, which is basically like network usage, CPU usage, etc. And we can, I'll just show an example which they've shown here. It's, I believe, yeah, they are monitoring the traffic of that particular VM instance. So if I just type network traffic, in my interface traffic DC instance +1, yeah, so this will monitor my VM instance for network traffic. And we need to just check, like, for now we are setting the threshold that we will be alerted if the network traffic is more than 500, this is I believe bytes per second for a minute, then we will be alerted. I'll just add this. Oh, 1 second. Sorry, I made a mistake, sorry. I needed to monitor my instance traffic. I monitored Elasticsearch traffic. Sorry. Yeah, using Google API's interface traffic for my VM instance. Yep, yeah, it is 500 bytes per second. So if my network traffic is more than 500 bytes per second for a minute, I will be alerted according to this alerting policy. Please note that 500 bytes per second is very, very less. This is just for demo purposes that they've shown 500 bytes per second. Okay, next. Now, we create an alerting policy which should alert us, right? But how will we be alerted? That is where notification channels are there. You can select a particular notification channel. I'll click on manage notification channels. Yeah, so there are various methods by which you can be notified. We have Slack, webhooks, email, SMS, etc. So if I enter my email here, then I will be able to see when I have been alerted. I mean, sorry, whenever this particular trigger occurs, then I will be sent a mail that this particular event has occurred and this threshold limit has been crossed. So for now, I'll just put my email address. Please don't send me spam emails. So I have created my notification channel. If I just refresh here, you can see that, and I'll click on that and say OK. So this particular channel will be notified whenever this alert is triggered. And no, nothing to do here. I'll just save that. Oh, sorry. Uh, I'll just specify any name. Okay, net leave anything. Notification channels. Yeah, inbound traffic. Obviously, you can name this anything else, but for the purpose of this tab, I'm not deviating from the given required name. And yeah, we can see this. We can see the network traffic, uh, which is more than 1 Mbps for some time. It was more than 1 Mbps for some time. So again, if this spikes up above 500 bytes per second, then I will be alerted on my email. Okay, I'll just check progress. Yes. So, any doubts still here? Then I will continue with creating a dashboard and a chart. Any doubts? No? Okay. What is PHP? PHP is basically a server-side language, a language in which servers are written. So for Apache, the default server language is PHP, I believe. That's why we had to install PHP. There was no use of PHP as such, like from our side for the lab side, but it was required as a prerequisite. Chirag is asking why was the email required. So Chirag, as I said, the alerts are made for some particular reason, right? That if, for example, my CPU usage is more than 90% for that particular VM, then there is an issue. I need to either make sure that my processes are running efficiently, or there is huge amounts of traffic, and I need to scale up my system. So for that, I need to be alerted in some particular way. So there are notification channels. We can have emails set up. We can have SMSs set up, or even webhooks or Slack, etc. We had loads of options. So currently, I use an email. So I will be emailed if there is any particular alert which was triggered. There you are asking is PHP also used to write APIs? Yeah, there you like backend languages are used to write APIs, and since PHP is a backend language, we can write APIs using that. No one visited your app, even then it was showing 1 Mbps in the graph. Good question, Rakesh. So basically, we had some instances running, some traffic and some connections to the virtual machine, which could be internally, like even Google monitors my virtual machine, right, for particular stuff like how much resources it is using, and internally also there are alerts set up, there are management modules set up, and that's why we did have some traffic there. Even for example, I did SSH, I installed some stuff. So again, that's also traffic where I was downloading and installing various software. So the monitoring thing also contributes to traffic. Yep. Some small amount of traffic would definitely be required because that particular instance is running on a network, and I am monitoring that instance externally. So some particular network traffic is definitely used for that. But yeah, like very minor, and it's essential, right? So it's okay if it uses some small amount of traffic because alerts are much more important than some amount of traffic used. Akshat is asking, does the dashboard show what the traffic was? Yeah, Akshat, I'll just show you charts so you can see what the traffic, CPU utilization, etc. was for the particular instance. Cool. So I'll move on to dashboards and charts. That was high. Okay. Yeah, so your dashboard is basically the main what do I say, the main place where we can see all our metrics together in one place. We can make a custom dashboard. So I'll just name this as given. Cloud monitoring lamp kickstart dashboard. And on this dashboard, I can add various charts to see the utilizations of my resources over time. I can click on add chart. Okay, one. So basically, in this particular lab, you can experiment with what kinds of charts you want to add. There are various types like CPU load for this, then network, receive packets, etc. So yeah, here this particular part here, free to explore what charts you can add. I'll simply monitor my CPU resources. Yes, VM instance and CPU usage. Okay, and you can tweak some settings, period, etc. I'll just select the default and save. So you can see my CPU usage per minute. It will update, and you can see that. And a second. Yep. Okay. Fine. Yeah, I am not adding the second chart because I don't know why. It's always an issue in my particular PC. When I add another chart and the whole tab slows down and I need to restart, I don't want to do that. So yeah, you can definitely add more charts here and explore. Now, secondly, so now here you can monitor, right? You can see what is going on in your instance. You can see the network usage, CPU resource, etc. Then there are logs. Logs are very important in such places, especially when you are doing stuff on the cloud, because that is your only source of truth, right? After everything is done, after you have seen some network spike, some CPU usage spike, then you can then like logs are the only way by which you can come to know that what went wrong. So logging is like for people who work constantly in the cloud, logging is so very important that they have special managers for logs. Like you can actually use queries like SQL. There are various applications which are made specially for logging management. So here, like we just show a small simple log manager. I mean, the log manager is not simple, but we'll see just a small use case for that. Navigation menu, logging logs explorer. Yeah, logging log explorer. Yeah, and this is actually a newer log explorer which Google Cloud has developed, but we would go back to the legacy logs viewer just simply to view logs without anything else. Cool. So now from here we can see the audit resource, basically any particular resource which you are monitoring. And we have one VM instance running, lamp 1 VM. I'll select that. And now we can see that we have all the logs of that particular instance. And if I click on play, it's actually to stream logs. Stream logs in the sense that they will start loading logs in real time. So as soon as a particular thing is logged, we can see that here. It will constantly update. So now we will try to start and stop the VM instance and we can check what happens. So you can see all these various some internal events are there occurring and which have been logged. I click here, I'll go to the instance, I'll start and stop it. And then you all will be able to see the corresponding logs. I think I'll leave this for you all to explore. if you start and stop the instance, you will be able to see instance shutdown, instantly restart, something like that, some logs like that. And yeah, so we had the uptime check, right? We had an uptime check which was making sure that our particular instance is always up and it was checking per minute. So if we just shut down our instance, then this uptime check would definitely tell us that there is a problem. Our instance is not working properly, or I cannot connect to the instance. So you all will be able to see that the uptime check has been triggered, and possibly, and definitely there would be alerts triggered there. So yeah, this was just a brief overview of how we can view logs, you can monitor your instances, and you can create alerts and stuff. Any questions? After that, I hope I could solve it out. We can add traffic charts to the dashboard, and that is how we can see the traffic. Yep, okay, cool. So I guess no doubts. I'll just end my lab, and I think now Shubhankar will teach the next topic. Thank you.
Yeah, thanks for that, Alida. Good evening, everyone. I will be teaching the HTTP load balancer with Cloud Armor lab, that is in track 1, quest 5, I believe. And I would advise you that while I am doing the lab, you don't follow with me by doing it practically, because there are a few issues in the lab, and the major issue here will be the time delay that is present. It takes like about 5 to 10 minutes for your changes to propagate, and that can cause you losing lab credits. So I'll explain the theory parts, and then I'll move on to the lab. But I'll advise you to just go along while I'm doing, but don't attempt the lab right now. You can do so later. Okay. So I'll start presenting my screen. Okay, so can anyone tell whether my screen is visible or not?
Yeah, Shubhankar, it's visible.
Okay, okay, awesome. Thank you. So today this is the infrastructure that we are going to build in this lab. So there is an actor here who wants to connect to your instances located somewhere inside your cloud. Okay. So he accesses the internet. Then from the actor's local IP, we pass into a load balancer. The load balancer passes down your information to the firewall. The firewall decides whether or not you should access the resource and from where you should access the resource. And then we get into a specific region. Inside those, there are multiple subnetworks available, and inside those, there are again separate virtual machine instances that from which one of those you can connect to. Okay, so this was a top-down overview which didn't make much sense. So we'll go from the bottom up. So let's say you need to access a resource VM1 from the left-hand side. Multiple such virtual machine instances are created, and as you should have studied by, you should have got it learned by now. We do this with the help of instance templates and managed instance groups, wherein you provide a startup script like what should happen when a virtual machine is created and who is there to manage it. Okay, so that is also what we are going to be doing today. Except that in the earlier lab you had done it using the G Cloud console, and now you'll be doing from the Cloud GUI. Okay, so let's say you want to access a certain resource, that is VM1, and also note that all the VM1 instances and all the VM2 instances are actually your application instances. Okay, so they are deployed into different regions under two different subnetworks. Okay, so there are three levels of hierarchy. There are two levels of hierarchy. I'm sorry. The regions, that is, you can deploy your application to multiple regions. So let's say in the lab, I guess this should be one should be US East one and one should be Europe West one. and under those there are multiple subnetworks. Now you don't need to know what especially a subnetwork is in detail because we will be covering that later. But a subnetwork, if you can think of, is dividing an entire network region into different smaller groups. Okay, so subnetwork, as it sounds like, is a subpart of a bigger network. Okay, so the hierarchy here is that you have two different regions under which there are different subnetworks. Let's say in a region you have a subnetwork, and inside that subnetwork you have multiple instances of a virtual machine running. Okay, all of this are then managed through your managed instance groups. Okay, you need to create rules for that as well. Now you go one step higher up to the firewall. Now what the firewall does here is it determines whether or not an user accessing your resource from outside should be able to get to your virtual machine instance or not. We'll see why that is important again. Uh, One step higher, you have the load balancer. Now, what the load balancer does is it should redirect you. It should redirect an user. I'm sorry. It should redirect an user to the appropriate region based on certain factors. Okay. So there can be multiple factors here. One of the primary being the network traffic that is there. So let's say region 1 is heavily crowded with network traffic, so that when an actor requests a resource, it can redirect you to region 2. Otherwise, one more important factor is the proximity. Okay, so from where the user is requesting a resource and how close it is to the region under consideration. So you will see later in the lab that you are requesting resource from US West 1. Okay, and so by natural limits and by natural logic, your load balancer decides that all of that load should be redirected to the region 1, that is US East 1. Okay, so that is what we'll be covering. And the upper two parts are just abstraction layers. The actor is requesting for a resource on the internet and how it should be considered. Okay, so this is the infrastructure that we shall be covering. Now a quick note on the load balancer. Okay, so the load balancer looks pretty simple here. What it does, in essence, should be as revised. It should redirect you to a certain region. Okay, here in this case, a certain region. What it does actually is it should redirect you to a specific server based on multiple factors that are working inside it. Okay? So now let's have a look at a load balancer in detail. A load balancer starts with an IP address. This can be a unicast or a multicast IP address. So there are different types of fancy IP addresses available. It is then passed down to forwarding rules. Okay. So the forwarding rules decide whether or not your data, not your data, but your IP address, whether or not your IP address should get passed down or whether there needs to be a proxy that needs to be present. Okay. This yes no condition situation then again passes down to proxy. So the target proxy then decides whether or not you need a proxy. And if you need a proxy, it decides one. Okay. How is that decided? If it needs one, URI map. So a URI map is essentially a map. So in other terms, a dictionary that contains like the target address to your proxy address, and that is used for mapping. Like, okay, this target proxy needs to be redirected to this point, and it shall be used in the reverse proxy as well. So, okay, I reached this proxy, and that means I need to deliver the content to this IP address. And then finally we have a backend service. Now a backend service is the core component of a load balancer in GCP, and a backend service is actually used to connect to your virtual machine instances. Okay. Now finally your backend service is continuously monitored by health check. So a health check keeps polling for a backend service. Polling in the sense it keeps asking for a backend service. Are you working or not? Are you working or not? If not, have you just got up and have you restarted on your own, or have you failed consistently, or something like that along those lines. Okay. So the health check is for continuously monitoring data. Okay, so this was all the theory part that we needed to cover for this lab. If there are any questions regarding to what we are going to be covering or some part of theory that wasn't clear, You can just ask it out. So are there any doubts? Okay, so Neha is asking, could you explain the use of proxy? And this is also a doubt for, I guess, Dhairya. Okay, so sometimes, let's say, I'll explain what a proxy is in general terms. A proxy is a substitute, okay? So, like, A is a proxy for B implies that whenever you are requesting for B, you are actually asking for A and vice versa. Okay, so those two are analogous terms. Now, what happens is in certain cases, your private IP should, not your private IP, your IP should not get disclosed. Okay, so in those circumstances, the cloud instance can provide you a target proxy. Now, what this target proxy will do is it will capture your IP and store it and give an IP address of its own. So let's say you are at 172.16 point something something. So the target proxy decides that okay, maybe you need a proxy right now, and so it devises a new rule. Okay, so that's let's say 192.168 or WhatsApp Wi-Fi address. Okay, so it devised a proxy for you. Now, this gets passed down to the URI map. So the URI map is basically a dictionary, not a general dictionary, but it is a sort of data type that stores these information. Okay, so like let's say I am requesting for a resource and this is my IP. So this is getting transferred into that IP, the proxy IP, and then that proxy IP is then passed down all the way to your virtual machine instances. Now, when the data is getting back up here, remember that the load balancer also sends you data. So when the data gets back up there, right now at the URI map stage, it only knows the proxy address. Okay. So at this point, it should know that okay, so this was the proxy address. What was it assigned to? So what was it assigned to was your IP address, right? And this is the process of this is the process called reverse proxy. Target finding out what was the actual IP when you have the proxy IP. So with that configuration, the proxy layer can then say that okay, so this was the proxy IP and this is the target IP. I received data on this proxy IP. That means I need to send data up to this target IP. And from there the layer goes up and up and your data gets passed on. So is that clear for Neha and Dhairya? Okay, so next up we have Pankaj who is asking, could you explain again what the forwarding rules are for? Okay, so the forwarding rules in essence are certain global rules that you decide for your load balancer. They may be global, they may not be global. Okay? Global in the sense applies to everyone. If not, so it applies for selective IPs. Okay. So just as I said that there are multiple scenarios where maybe you should not get access to a certain resource, but you are asking for it. Okay. So one of those layers acts in the firewall layer. Okay, so that is blocking certain attacks. That is only for like harmful purposes, or you can say so. But in general terms, there are also scenarios where, like I said, you should not get access to a resource. But it's not like you are at fault. Okay, so let's say you are accessing a secure route without logging in first. Okay, so if you are not logging in first, technically you are not allowed. So these are some of the rules that you should configure in the load balancer. So this would ensure that let's say you are hitting the secure route, and then it should say that okay, you are hitting the secure route, but you are not authenticated. So you should not access that resource. You need to log in first. Okay, so these are the rules that get configured in the forwarding rules. So Pankaj, is that clear? Okay. So next up we have Bhumika's question. So in short, the VM instances won't know the real IP address which has accessed it. Right. Yes, even say so partially. like I said, not every IP address gets a proxy address compulsorily. Although majority of the cases, it is the case that you always get a proxy IP. Say 1% or 2% of times you won't get a proxy IP, and your actual real public IP gets down all the way into the virtual machine layer. So yes, Bhumika, in short, you can say that the VM instances won't know the real IP address in majority of the times, majority of the times. Okay. So I guess this answered Bhumika's question. Next up, we have Akshat question. Can you explain URI map versus API endpoints? What resources are we talking about in URI map? Okay, so URI map, as I said, URI map is used for like creating certain map resources for like as I was explaining earlier in the proxy part. You need to know what IP address gets configured, which part of your public IP address. Okay, so all of those gets covered in the URI map. I couldn't get your question on the point of API, URI map versus API endpoints. So, like, could you elaborate it a bit? So, like,
I heard accessing resources through a request तो मुझे लगा API endpoints is connected to URM app.
yeah, the process is the same, but you cannot say that it is just like an API endpoint. The process is same that you generate an URI map for accessing certain resources. That is similar to the way we access API resources. But yeah, it's the same concept, but on a conceptual level.
Okay, thanks.
Okay. So any more doubts? Okay, so we see that we don't have any doubts. So I'll move on to the lab then. I'll just configure the lab. Just give me a moment. So let's just keep it on. So we will need this for this lab. Because the first task in this lab is to create a firewall rule. And like what are firewall rules? By default, all your virtual machine instances, everything that you create in GCP is by default restricted to internet access. Okay. So like if you don't configure a firewall rule, you won't be able to connect to internet. So let us do that first. Let's VPC network and firewall. In firewall, you can see that there are certain rules already given. So that's default allow ICMP, internal, PDP and SSH. So you should be aware by now that SSH is used for connecting to virtual machine instances from the Google Cloud here. ICMP is a protocol for returning that acknowledgement whether you have connected to a resource or not. Internal is used for ingress traffic. That implies that it is used for like traffic that is occurring inside like content within the content, not the containers, within the virtual machines. And RDP is like on a similar scale. It works in the same way. So you can see that there is a default naming convention here. So that's default, then followed by allow, followed by the protocol name. Okay, so default is the default subnet that every GCP project gets. When you create a lab, you shall also see that there is a default subnet that is always allotted to you, and all of us create all the work configurations within this default subnet. So we'll create a firewall rule now. So since this should apply allow HTTP. So let us do that. And no logs, network default, priority 1000. Uh, let's see the target tags. So we have a target tag that is HTTP server. So what this implies is whenever you have a virtual machine instance with the tag of HTTP server, those shall be tracked by your firewall. And if it sees that okay, internet resource is trying to access it, it should say that okay, since this is HTTP server, I need to give it internet access. So source filter IP ranges and source IP range is whitelisted. So so please note that this should not be doing in a production environment. This is like whitelisting every IP that's possible currently, and ideally you should only allow source IPs that you can configure and you have knowledge about, right? Okay, so TCP 480. So this is the protocol and port that I am allowing. So I am allowing the TCP protocol to access port 80, and by this, whenever I receive an incoming internet request from port 80, I should know that okay, maybe this needs access, so I'll allow it. Okay.
Shubhankar, can you elaborate the 0.0.0.0?
Okay, so 0.0.0 is basically the whitelisting address. Whitelisting generally implies, as you can, I'll not create another firewall rule, but you can see here that there are specific source IP ranges. Okay, so this can be anything like 35.216.2.3/16. Okay, so this is a classless addressing based system where like I won't go much into detail, but this allows the firewall to detect that when I receive okay, so maybe that's not the correct one, but yeah, you get the point that whenever I receive any incoming traffic from this port, from this IP address, I should allow the resource to pass through. Okay, so let's say I am at this IP currently, 35.216.2.3, and then I request a resource for my virtual machine instance, for my application basically. So it should say that yes, I have this whitelisted right now, so I should allow you. But when you are doing a 0.0.0.0, that basically implies that you are allowing everything. So all ports at all addresses, not all ports, all addresses get allowed to pass through. So I guess that was clear. So let's get back to where we were. So yes, you can see the default allow HTTP is active currently. It is supporting TCP at port 80. Okay. Let's move on. Now we need to create health check for the firewall rules. Okay. So health check.
Shubhankar, I had a doubt. You are reading the steps and doing, right? Like
Reading
the theory that is given in the Qwik lab.
Yes, I am doing the parts like what I should be writing and what is the configuration. Yes.
So can you also show the theory part like it is given there and we are doing that? It's simultaneously.
Okay, I'll just have to present the window. Okay, give me a moment. Okay, so can you see the resource?
Yes, yes.
Okay, awesome. So now we'll be doing the firewall rules. Like there's pretty stuff given already in the what is it, the quick lab. Okay. Hello, can I go on mute? Okay, okay, fine. Okay, let's move on. So now we'll be doing another health check firewall rule. So that allows us to monitor for incoming traffic, and it allows you to see whether uh, your virtual machine instances are up and running for those IPs. Okay. So here they have specifically mentioned that they only need to load balance from these two ports. So we'll be doing the same, and let's configure this. Default allow health check. That's the HTTP server tag again that we are specifying. Let's copy these IP addresses. So
Sudankar,
for
we have a
that,
doubt. The lab name is Load Balancer with Cloud Armor. So what is a Cloud Armor?
mm, okay, so like there is a specific part related to cloud armor, and I thought that I would get to it when the time comes. So yeah, if you could just hold on for a bit more longer, we will actually get to the part where we are using cloud armor. So if you could just wait for a little more while. Okay. Okay, so please note that in this case, for creating the firewall rule, I haven't explicitly specified any port. So the health check would run for all ports that are receiving TCP traffic. Okay. Okay. So that's now again, this is one of the parts that we have already covered earlier. The instance templates and managed instance groups. So instance templates are basically bash files, the scripting files that are written to specify what JCP needs to do when it creates a virtual machine, right? So whether it should give a specific what should I say, pre-tags, or what should be the boot test that needs to be done, and all such stuff. That is, all of those are written in the instance template file. What a managed instance group does is it keeps track of all the template of all the virtual machine instances created using an instance template. Okay, so it keeps track of every such object. So we had done this using the G Cloud SDK in the CLI, but now we'll be using the GUI to do so. Let's proceed. Just excuse me a second. So this is US Eastern. Okay, so notice that in the earlier lab we had created a startups.sh file. In this case, we'll be given a startup script URL and we'll be using that to access. Basically, there is a file hosted there right now. So using that, we can access the startup script necessary for creating, necessary for creating the managed instances. So let's these are like points that were not covered in the earlier lab that included managed instance groups. So this is basically allowing for all the networks or what should I say? Allowing for specific networks, how it should be configured, what should be the interface that needs to be configured for all of those. So all of this is available in the management and networking points. Okay. So we'll just subnet default as HTTP server. Note that we are commonly supplying in the HTTP server tag that allows for easy access to all the virtual machines. Okay, so now note that we have configured the network to default and the subnet to default US East 1 under certain IP range. What this would do is it shall create all the virtual machine in the US East 1 region only. Okay, under the specific subnet. So we aren't really concerned about the subnet right now, but again you can change this, and so this allows for flexibility in where you should create your instance templates and where your virtual machines need to be there. Okay. So that's all for the configuration part service. Yeah. So now, as in the lab that mentions that we have created a managed an instance template to run for US East 1. In the same way, we shall create another one to run in Europe West 2. Okay, so let's do the same part again. Europe West 2. The rest of the stuff stays the same, but we will configure the networking again. Note that we need to change this to Europe West 1 this time around. Okay. So now this tells you that all the virtual machines that are going to be created from this template is going to be created in Europe West 1 region only. Okay. Let's click create. Okay, so now we have two templates ready and it's time for managed instance groups. So as stated earlier, managed instance groups manages all the virtual machines created using a template. Okay. So just as we created instance templates for US East 1 and US Europe West 1, we have to create two managed instance groups as well. Okay. So let's do that. Okay, so just check this out over here as well. That once I selected the US East 1 region for creating the managed instance group, you can see that I cannot select the Europe West 1 template anymore. Okay, so all I have available is always the US East 1 template. Let's see. We need to change the CPU location. Okay, so this is a metric. Okay, so let's observe again that we have certain amounts of points that we can have here. Okay, I'll just configure once and then tell this. So this is 45. Okay, so see, the minimum number of instances is 1 and the maximum is 5. So that means that all the virtual machine instances under this group can grow from 1 to 5 automatically. Okay, so that is the auto scaling mode that is activated right now. Okay, and when should you then create a new virtual machine? That is the question. So there has to be a certain metric to understand that okay, the load here is very high, and so I need to create a new virtual machine right now. So that is what we specified here. Let's CPU utilization at 80%. So this is the peak performance condition. After this, your instance group decides that okay, I need to create a new virtual machine. Okay, it can do so up to 5 parts. Okay.
So currently you are just viewing what he is doing. Just after the to start with the lab, so we'll understand completely what he did till now.
Yes. So just as I created for US East 1, I need to create one more for Europe West 2. Let's do that. Was it Europe West 1, I guess? Okay, my bad. Europe West 1. Europe West 1 template, and we need to change the metric here probably. That's CPU utilization at 80%. Five instances. Take a second to cool down. So it's the same configuration. Just note that I configured it for the region Europe West 1, and so I was only given the option to choose Europe West 1 template. Okay. The rest of the content stays the same. Let's create. When this is on, any questions up till now? Why is CPU utilization? Vishal is asking why is CPU utilization set to 80%? What happens if we set more on this? Nothing happens basically. The Vishal, the point here is you need to provide a certain limit. Okay, so how much CPU your virtual machine should utilize before it's too much. Okay, you can do 100% as well, but that won't do any good to your virtual machine, right? So you need to provide an upper point to what should be the maximum capacity that your virtual machine should be working. And if it goes beyond that, so it's time that we move to another solution and not just put load on the existing virtual machine. So there is ideally there is no problem in setting it to going less, but like it's a trade-off basically. So the trade-off here is with the number of instances versus the CPU utilization. So as a network administrator, you have to be aware of like how much load you need to put on each virtual machine and so on. So these are all metric terms. Okay. So is that all got clear? Vishal? See every time. Okay. Okay. So at this point, our virtual machines should be running. Let's see if they are. See, now notice that there is, this was probably mentioned in the startup script, which we hadn't been able to read. But notice that they have a prefix, right? So that's US East 1 MIG, then this, Europe plus 1 MIG, then this. Okay. And currently they are only running at one instances each. Let's try opening both of those. Okay. Awesome. So our virtual machines are configured and they are transferring internet traffic as well. You can see this will change. Okay, this is the dynamic IP. Your IP address will be different from mine, but this will be same up to also the region and zone shall be same up to the point where we configure the load balancer. We haven't yet configured the load balancer. Okay, so similarly here, that's a different server and this is a different region. Okay, so let's move forward. Basic simple question that always has an answer given before the question itself. Okay, so now comes the big part that we need to configure the load balancer for like the entire traffic. So notice that we have very vivid virtual machine instances, right? One is running in US East and one is running in Europe East, Europe West. So based on that, we need to decide certain configs. So let's start with the load balancing part. So okay, so given config here is from internet to my VMs. So let's continue on that. The VM is HTTP That's HTTP load balance. Okay, so just as I mentioned earlier in the draw.io diagram as well, that backend services are the bottommost layer of any load balancer and they are actually used to communicate to the region or other backend services. So we need to configure the backend first before going up and above. Okay, so we'll start again in the bottom up fashion. So let's start with the backend configuration. Backend services. Let's create a backend service. This is named HTTP backend. So let's do so. HTTP backend. There's an instance group here. Let's state that. Next up. US East 1. Notice that it detected your region automatically. So running at 80. balancing mode at rate and maximum PS at 50, capacity at 100. Okay, so what we did here is there are balancing modes available, right? There are two balancing modes available: utilization and rate. Utilization again depends on just as we configured earlier, that is the CPU utilization, and a rate basically means the number of requests per second. Okay, so that's this RPS, request per second per instance. Okay, so we are configuring it at maximum 50. So, let's quickly write this. Okay. So once your virtual machine reaches a transmission rate of above 50 requests, you need to start load balancing, or your load balancer needs to check like what should be done right now. Okay. So notice that we did this for the instance group US East 1 MIG, and this means that again we'll need to configure it for Europe restaurant. This should be again 80. For the sake of demonstrating what happens here, we set the balancing mode to utilization. The maximum backend here is 80 and the capacity is 100. Okay. So we have two backend services running for both of the regions. And let's create a health check now. Check. Running at TCP port 80. Okay, so there are again different configs for like host and path rules, but for the sake of this lab, this won't be needed. Okay. So then we'll move on to the front end configuration. The front end configuration is basically from where your request might be arriving and how you should accept it or not. Okay. So let's stay as it is. This is at HTTP IPv4 ephemeral IP address. That means that all the IP addresses have a forward slash, then followed by another number, and then at port 80. So, okay, this looks done. Okay, so we need to configure another front end for IPv6. So let's do that. Fetch protocol, HTTP IP version IPv6, running at port 80. Right? With this, you will have two IP addresses, one for the IPv4 and one for the IPv6. Looks good. Let's create the entire load balancer here. From this is where the delay starts to kick in. So like I'd advise you to finish this part up to like let's say 20 minutes, because from here some changes take up to 5 to 10 minutes to like travel and get accepted, so that can cause major concerns. Okay, so let's wait for the
We'll be waiting for 5-10 minutes. Or like we
no,
can just explain the last step.
Yes, for the last steps, I'll see if the delay is more. I'll just explain the part. But this looks like it's going to be good right now. So let's see. Okay, let's see. Okay. So this is how our HTTP load balancer should be working. Okay, so it should transfer. It should send basically is responses from the region where it is closer to you. Okay, so if you are in the US West and you ask for a resource, you have a resource available in US East, right? And so by definition, it should return from there only. And then again, it would then depend on whether the site there is heavily clogged, and then it would decide that okay, I should now move on to Europe West 2 for getting it. Okay, so let's see here. Load balancer. Yes, so this is the part that I was talking about. Takes a pretty significant delay, but like as mentioned, if your resources are configured, you will get that tick marks that signify that what you have been doing is correct, but it has not yet propagated to the region. They have also mentioned a caution that it shall take up to 5 minutes, and in my case, when I was attempting for the first time, it took me 15 minutes. So I was literally panicking whether or not my lab would succeed. So okay, that's so now this comes. Here comes the part where we'll start with what is Cloud Armor. Okay, so what was her name? Neha, thanks for waiting so much. And okay, so basically now what we will be doing here is I'll explain the part and then we'll move on to doing the practicals if we have time. So what this does is you are going to create a new virtual machine at US West 1. Okay, so that's given here. Now, since you are at US West 1, by default you should be receiving resources always from US East 1 because that is closer to you than Europe West 1. But how do you test it? Okay, you can't just manually hit the route every time or like if even if you're capable of hitting the route many times, what is the max that you can be hitting, right? You are going to the previous route, hitting an enter button, then you are getting the resource. Okay, so that's not how testing works. To actually state how load balancer works, we need to stress test it. Stress testing is a form of testing that works in all situations, and stress testing is basically that you pump a lot of data into what you are targeting here. So we are targeting the load balancer here, right? So we are pumping an insane amount of data into the load balancer. So in this case, how can we pump in data? That means we are requesting for resources. That is what we have been doing so far, right? So we are continuously asking for resources at a very insane speed, right? That is what is stress testing. Okay? And when you stress test that you need to add a certain command that's siege here, so that is given. All of this you need to run inside the virtual machine, and I'll get to that. So what this does is it runs requests at pretty significant speeds, right? So this is technically running 250 concurrent thread. This is running 250 concurrent threads per second. Okay, so like if you keep this on for 3 to 4 minutes, at the end of it you will see that your server got requested for like 5 to 6 lakh times. So that is where stress testing comes into picture. Okay, and that is the exact point that we need to convey here. So we will see a graph like this that signifies what is happening. Okay, so you created a virtual machine instance at US West 1, right? So the US West 1 traffic always gets routed to US East 1. But when you have pretty insane speeds of requesting resources, the entire bandwidth here is clogged, right? And then at certain cases, you will then start getting resources from Europe West 1. Okay, so that is what is happening here. So this is all good when you are asking for resources, right? Here you know that I am the one doing it, and I am stress testing it. But what if someone else starts to do it, right? So that is a distributed DOS attack. That is one of major forms of cyber attacks that works on servers. It is basically attacking from multiple points to a single endpoint, right? So everyone starts to requesting you for resources, and at very high resources, your load balancer will start not let's say degrade, but will start to divert your load traffic, right? Just as you saw in the chart, it starts diverting your traffic.
Shubhankar, can you explain this again, graph?
Okay, so the graph is visible right now, right?
Yes, it is.
Okay, so see that you will be creating a virtual machine in US West 2 region. Okay, so US West 2 is very near to US East 1, right? And so by default, your load balancer is always configured to return data from where it is closest to. So that is proximity analysis, right? You are in US West 1 and US East 1 has a resource there, right? So your load balancer decides that okay, I should always give the resource from US East 1. So you don't face any issues in getting resources. But when you are using Siege, under those circumstances, there is an insane amount of request, right? And the cloud is currently seeing here is that 250 users are asking for the same resource at the same time per second, right? So there is heavy internet traffic currently for it. And so at some point, your load balancer will automatically decide that I need to transfer the route from US East 1 over to Europe West 1. Okay, so I should now start getting the resources from Europe West 1 and send it back to you, because there is an insane amount of requests that you are keeping on continuously asking. You are asking that I should get this again and again and again. So your load balancer now decide that okay, this is maybe enough for the US East 1 zone, and like this is probably the max utilization that it has reached, and so I need to shift my focus now. This is a standard graph that denotes what happens in stress testing, right? Initially, there is a heavy bandwidth in the region that is very close to you, so that's US East 1 in our case, and then slowly you see that the network traffic starts getting flowing into different regions, right? All the different regions those are available, all the data will start flowing into it from other sources as well to like compensate for the internet traffic that is happening. Okay, so like is the graph part clear?
Yes.
Okay, so yeah, so now just I was explaining that this is all good when you are testing it. When someone else is testing it, it does not feel that good because there is a heavy load on the server, and this is where Cloud Armor comes in. Okay, so Cloud Armor is a security policy for GCP. What it does is it allows you to decide whether certain IPs should get access to you or not. Okay, this is not the same as in the firewall case. Okay, so please remember, in the firewall case, as I had explained through an example, that maybe you want to get a secure route, but you are not logged in, so then at that point it decides that okay, no, you shouldn't access this resource. Here you are creating actual security policies. So what you are doing here is you are telling the load balancer that whenever you see any IP, whenever you see this IP requesting for a resource, just straight up deny it. Okay, don't pay any attention to the request that you are receiving, and just straight up keep on ignoring the IP's request resources. Now this secures your application from as I was mentioning DDoS attacks. So once you get to know that which IP is actually asking for resources, there are multiple ways you can ask for which IP is here. So just as in mentioned here that in BigQuery you can see the VPC flow logs. So this is one of just another logging mechanism that's working behind the scenes for you. And what that does is it allows you to create special security rules to like say that this IP address should not be allowed under any circumstances. It's not the case that he is not authenticated or something like that. He is trying to get into the system, or even worse, he is trying to break the system. So in those cases, that you should like create for special security policies. So what happens next here is that you create specific IP. In this case, this is the IP like for your virtual machine instance that you created. Okay, so every virtual machine that you create has an external IP, and you provide this IP here, and you say that I should deny this with a deny status of forbidden. Okay, so 403 is status code for you are not allowed to get into it and just get lost. So that's what 403 stands for. And with that, what this would do is, like I said again, your IP address is now blocked. In short, in very brief terms, your IP address is now blocked from any request that you ask for. So next time you do a resource request, so you hit that route, nothing happens. You get a straight up 403 message that you cannot access to this resource because you are forbidden. Okay, so that is what the entirety of Cloud Armor is. Most of the part, like 80% of the part, is devoted. You can see in the leaflets as well. 75 100. So that 3/4 of the part is entirely devoted to creating an HTTP load balancer, and the last part of it is how to protect your load balancer using Cloud Armor. Okay, so I'll not proceed with doing the task because it's pretty straightforward. As you can see that these are pretty simple steps. There is no theory part anymore. It's just entering the steps. I'll not proceed anymore. But if you have any doubts, I'll be happy to. Okay. Vishal had a follow-up question, but then we are wasting the 20%. Isn't there a solution to save this 20% utilization? So, Vishal, as a matter of fact, no CPU can actually work at 100% utilization. Let's be honest on that. And there has to be certain limits on what you are putting onto this system, right? So even in your computer, if you can see your CPU memory usage, you will see that it caps at around 85 to 90%, and any more than that, and then your computer will either start lagging or it will start getting very hot. So that's why we always keep a limit. So there is no 100% full utilization, but yes, so we keep certain limits for that. Okay. Then Vishal has another question. Then why aren't we scaling it if you are having a load on the server? Okay, so you are asking about the graph part, right? So see, the point here is that you will have virtual machines created. That is what I was telling you, that CH is an excellent tool for stress testing, as Palak has already mentioned in the chats, that it is an excellent tool for stress testing. It focuses very much on how many requests you can put it into, right? And so if you can see your virtual machine logs, that you will realize that the virtual machine instances get created. It is not that they won't get created. They will scale up, and but there is a point at which even scaling will not help you, right? And at that point you need the load balancing. That is the exact scenario case for why load balancing is used, right? So whenever you always have options of scaling, but when I created the instance groups, you should have noted that I had set a max limit to 5. So only 5 virtual machines were maximum possible, and any more than that, and you'll have to start redirecting your network traffic. So that was Vishal's doubt. I hope it's cleared right now. And next up we have Rakesh's doubt. Shouldn't this IP be chosen dynamically? The IP of the machine which requests continuously. Yes, Rakesh, you are correct on that part. But hey, how should I put it? You see the forward slash right there when I was adding for resources, right? Even in the 0.0.0.0 case, I'll just get to if it's possible. Where was it? You see here, in here you have specified certain ranges, right? So this forward slash followed by 22. These are all heavy networking terms, and to be honest, at this point in our curriculum we are learning this. So at some point you will also learn this, but Yes, this is what it allows. Okay, so this is an IP range. Okay, it's not exactly one IP. So your virtual machine instance always has one IP, but the your GCP instance when you are creating Cloud Armor requires you to put an IP range. So when you put this forward slash, you are actually telling that there is a range of instances. There is a range of IPs here, but they have something in common from 130.211.0.0. Okay, so there is something in common, and that is decided by the 22 part here and the 16 part here. Again, this implies that there are a number of IP ranges here from 35.191.0.0. But again, there is something in common from this IP address. So, like if you are really interested into getting into this, I would suggest you to read on DHCP protocol and classless addressing, because that is the entire part of what I was trying to cover. But if you read it at your own speed, you shall be able to engage what is actually happening behind the scenes. So
Can you
for the
repeat
sake,
the topics once again? Which topics you told?
okay, I'll just put it up in the chat box. So that's DHCP. It's DHCP and classless addressing. Okay. So like if you have in terms of one of our professors, if you have a literature survey on this, you will be able to understand what is happening behind the scenes. But for the sake of simplicity, we can say that it is indeed an IP range, right? It is an IP range. So see, our load balancer indeed works, and it is requesting from US East 1 right now. So it's working correctly. Okay, so that clears Rakesh's doubt. Any more doubts? Does Siege send requests from different regions or all concurrent users from one? Yes, Pankaj, they are all concurrent users from a single machine. You are running these commands from your virtual machine, right? You will be running these commands from your virtual machine, and so it is a form of disguise. Basically, you are creating separate. Like how should I explain it? It works under the hood to create many such users who are requesting resource. It is working for one machine only, but from one machine it is requesting for like 250 users at the same time. So they won't be from different regions, because Siege is an open source tool, and it is not only for GCP. Okay, so Siege is used for stress testing in many cases, and so it is an HTTP based stress testing tool. So what that implies is that the points of regions or zones are valid only in GCP, right? So it does not send requests from different regions. It sends all the requests from one single machine under the hood of different users. Okay. I hope this was clear. Pankaj? Something like cloud armor is what would deny me if say I send get request with a high frequency. Yes. You are correct on this part. This is what cloud armor exactly does. It provides a shield of sorts to decide whether or not you should access something or not. And it's not only about get requests, all types of requests.
Okay. So, with this, we complete the 3 sessions. Just one last request from you. In the activities section, I have taken a poll. If all of you can answer the poll, and then we can.
Also, before we end, for those who are asking what is Fluently, Google Fluently. Fluently is basically a utility for managing logs. So, kind of, we have lots of services putting in logs to Fluently, which manages it and can store it or send it to analysis programs. So, Fluently is the managing utility for logs, the unified logging layer. And Google Fluency is basically some tweak on that on Fluency, and it is created by the Google Cloud Platform team so that it can work properly with Google Cloud Platform instances.
Okay. Can all of you see the poll? If you can answer that one. It's beside the chat section. You can see in the polls. It is active now. Today we have covered 3 labs, so you can do the labs. And if you have any doubts, you can always ask us. So anyone waiting for the SQL lab? Or you want to do the labs on your own? On our own. Okay, Neha. You can try all the 3 labs. All the concepts that we discussed today are associated with a lab, and I have mentioned those labs in the document, right? So you can refer that and complete the lab. So with this, we end today's session. We will keep our session till 7:30. Today it is 7:45. No worries. Thank you all for attending. This session will be uploaded on YouTube as well.
Thanks, everyone.